machine learning, what today's AI does is it makes that prediction done by a machine and decouples it from human judgment. And that's what's so disruptive. I think with AI, more people are going to win than lose, but that's not to say that the people who are left behind, we should just ignore them. So like, I am worried in that sense. But I'm optimistic about high-skilled versus low-skilled. And we build some training programs to help nurses and pharmacists and others leverage those prediction tools. What we can think of as upskilling millions and millions of workers.
This is Randy Xu with Luohan Academy. Hi, everyone. Thank you, everyone, for joining today. It's been a hectic week for AI news from all sorts of firms, Microsoft, Google, Baidu, and others. So we are very privileged today to have Professor Avi Goldfarb with us. So I want to start with two housekeeping notes. First, I do advise holding most questions until after Avi's presentation. But if you do have a pressing clarifying question, the optimal way is to put it in the chat, and I will monitor it. Second, since this is being translated into Chinese and languages don't map one-to-one, I did want to clarify a crucial word today, prediction. So in English, prediction often suggests a forecast of the future. However, in the context used here, it's a broader definition. Prediction is the ability for a machine to predict an appropriate output for a given input based on learning on large data sets. So for example, ChatGPT predicts what a good response is to a question. So I hope this clarifies an important term today. So now to the speaker. Professor Avi Goldfarb is a recognized global leader in studying the impact of AI on business and society. He is a professor of marketing at the Rotman School of Management at the University of Toronto, where he holds the Rotman Chair in AI and Healthcare. He is a research affiliate at the Vector Institute and the Schwartz-Reisman Institute for Technology and Society. Both are leading institutes for studying AI and advanced technologies. He is also an organizer of the Economics of AI and Economics of Privacy conferences at the National Bureau for Economic Research. But even before AI, Avi has conducted leading scholarship in the digital economy. He is well known to all of us at Luohan for research in platforms, marketing, business models, and so on. So given this, it was no surprise that Avi took a lead in studying developments in AI. But there was also a serendipitous element. The University of Toronto has actually become a global mecca for AI studies, exemplified by pioneers such as Geoffrey Hinton, whose work directly led to ImageNet and Google Brain. Avi helps to lead the local Creative Destruction Lab, which hosts entrepreneurs, including many in the AI field. With his collaborators, Ajay, Agrawal, and Joshua Gans, who is a fellow professor, and I may add, a Luohan Academy fellow, Avi published in 2018 Prediction Machines to outline an economic framework for AI. A few months ago, the trio published their latest book, Power and Prediction, to discuss how organizations can evolve systematically using AI. I advise our audience to pick up both books. It's actually available in Tmall. When I read them, I especially appreciated how the authors combine their knowledge and frameworks from their scholarship with their experience with practitioners at the forefront of the field. So when I found out that a visiting scholar at Luohan, Verena Chud, was a student of Avi's, I immediately got in touch. So again, we are delighted to hear from Avi today at such a critical juncture in this technology, given all the flood of news. We really could not have predicted the timing any better. So Professor Goldfarb, please.
Thanks, Randy. It is a real pleasure to be talking about AI this week and to be talking about these technologies to you guys in particular. Let me just want to get my screen organized so I can see what's going on. There we go. Okay. Ready?
Yep.
So this is our new book, and underlying the reason I'm here and the reason we're excited is extraordinary excitement and hype around AI generally and generative AI in particular. So since our book came out November 15th, ChatGPT arrived at the end of November, and we were blown away by how much progress had been made in language models. So you'll see headlines like it's a game changer. We might need to welcome our future AI overlords. It's a $1 trillion, $23 trillion industry, maybe more, maybe less. And it's the talk of the global elite. Think about AI. He's the only psychologist to win the Nobel Prize in economics. Right? Clearly, AI is going to win, and how people adjust, given that hype, is a fascinating problem, given the potential of this technology. And for some people, it's a fascinating problem. For many of us, it's a terrifying problem. For those of us who have much of our careers ahead of us, we think through, well, if the machine's intelligent, what does that mean for us? How can we really understand and adjust to these incredible changes that we've seen with technology? I think underlying the hype and that anxiety is a lot of confusion about what we're talking about when we're talking about artificial intelligence. We get this sense sometimes that we're talking about the machines in science fiction, where these are machines that can do just about everything we humans do. Sometimes they listen to us, sometimes they don't, and that's how you get the Terminator or the robots in the Matrix or Ultron. But ultimately, science fiction has trained us to think that we should expect machines that can do just about everything humans do, maybe even all sorts of things better. And the worry is whether these truly intelligent machines are going to listen to us or not. That idea of an artificial general intelligence isn't crazy, but it's important to recognize that it's not the technology we're talking about today. Artificial general intelligence, the machines that we see in science fiction, has been 20 to 50 years away since the 1960s. And if you talk to the experts today, it typically seems to be about 20 to 50 years away. Technology we're talking about today instead is based on advances in a particular branch of computer science. In fact, a particular branch of computational statistics called machine learning. And machine learning is prediction technology. And it's prediction that's gotten much better. And by prediction, as Randy this talk, I'm not necessarily and only talking about understanding what's going to happen in the future. I'm talking about using information you have to generate information you don't have. I'm talking about prediction in a statistical sense. So our first book came out in 2018, and it was clear that there were these massive advances in artificial intelligence, massive advances in prediction technology that were going to lead to new opportunities. And with our economist lens, Ajay, Joshua, and I were economists. With our economist lens, we said, well, that's going to lead to a drop in the cost of prediction. Right? Prediction's getting cheap. And when something gets cheap, you do more of it. This is Econ 101, right? The very first thing you teach in the first class to undergraduates in microeconomics is that when something is cheap, when the price falls, you buy more of it. When the price of coffee is cheap, people buy more coffee. And so when the cost of prediction, the price of doing machine prediction, falls, we see more and more and more prediction. And that's exactly what we started to see. We saw banks using prediction machines to assess whether you're going to pay back a loan. So that's an old-fashioned prediction problem, right? Going back hundreds, if not thousands of years, you'd walk into a banker or to a lender's office, and they'd look you up and down and predict whether you're going to pay back their loan. And increasingly, lending institutions are using machine learning tools. They're using artificial intelligence to predict whether you're going to pay them back. The insurance industry is another industry that's using AI for prediction. They're in the business of prediction. It's what the insurance industry does. They're trying to predict whether you're going to make a claim, and if you make a claim, how big that claim is going to be. And increasingly, insurance companies are using these AI tools, are using machine learning to predict the underlying risk, the likelihood of a claim for underwriting. And as prediction's getting cheaper, we're starting to realize that there's things that can be framed as prediction that decades ago we would not have thought of them as predictions. For example, medical diagnosis. Medical diagnosis is prediction. What does your doctor do when they diagnose you? They take in data about your symptoms and they fill in the missing information, the cause of those symptoms. That's prediction. And image recognition is prediction. There's scientists in the 1960s figured out that we can think about the way our eyes work as your eyes take in light signals and they fill in the missing information of a label and a context. It's prediction. But engineering-wise, we didn't know how to solve images and image recognition with prediction until much more recently with the rise of machine learning, with the rise of AI. OpenAI's advances are advances in prediction. If you ask a query, it's going to try to predict the set of paragraphs or the response to that query, predicting essentially word by word which word follows the next one. The generative AIs out of OpenAI, for example, DALL-E, are also prediction. What does somebody want when they ask for a picture of an astronaut on a horse in the style of Andy Warhol? And that is a process of filling in the missing information of the response to that query. It's still fundamentally about machine learning technology, just using more and more and more data you have to generate the data you don't have. Randy mentioned the Creative Destruction Lab. The Creative Destruction Lab is a program that we started at the University of Toronto in 2012. It's now in 12 universities around the world. And it's a program for science-based startups. And a lot of our most successful startups have been in the AI space. In that very first year, the Creative Destruction Lab back in 2012, it was the first time Ajay, Joshua, and I had really seriously heard anybody talk about AI. It's a company called Atomwise, and they were trying to predict. They're using AI for drug discovery. If you put yourself back 10 years, that seemed insane. Trying to use AI for drug discovery. It was trying to predict which molecules bind with which proteins. It was prediction to try to figure out which drugs were going to work. Okay. Then over the years, we've had these other companies, BenchSci, Ada Support, and others, all using predictions within existing industry workflows to try to make those companies more efficient, whether it's in drug discovery or in customer support or in the legal industry, banking, insurance, etc. As we've seen, go ahead, Lon.
Avi, yes.
Hi.
Can you help the audience to define what do you mean by prediction? So basically, I think from the data or using the models, or the AI, you can do a couple of things. One, obviously, to understand the rules, the nature of what's going on right now. And when usually people say prediction, they are talking might mean something that will happen in the future. Now, between now and future, there's something about the assumption about the stability of your distribution or whatever it is. So there's several things involved. So I think if you define this a little bit clearer, it helps us to know exactly
Absolutely. Okay, that's a great point. So it's prediction in the statistical sense, using information you have to fill in information you don't have. But that what does that involve technically? That involves the data that you have on hand to try to fill in missing information that's like the data you have on hand. And so the prediction machines are at their best when you have data on the support of what you're trying to predict. Okay, so the thing you're trying to predict is like the data set you have. The future is like the past if it's the future, or the new image that you're trying to create is like images you've seen in your existing data. They fail, this is actually an important point, when it's off the support of the data. So trying to make a prediction on something that you haven't seen before, and you haven't seen something like it, that's when your predictions are going to fail. That's typically, in econometrics, those are causal inference problems. And you can sort of divide the statistical world into causal inference problems and prediction problems. The massive advances we've seen in machine learning are primarily about prediction problems. And so it's about filling in missing information on the support of the data you already have. There are a handful of tools in the background that are about proactively collecting data in order to make predictions that would seem to be off the support of your existing data. So reinforcement learning, for example, is you can see it as a data collection tool to simulate data that's off the support of your existing data set. And there's a handful of tools there. But so what we have here, we have prediction technology. The predictions are going to work really well on the support of the data that you already have. So the known knowns.
Right. So I think in the AI, there's several issues we're still kind of debating today. So, so one is, of course, is the causal. At one point, people talking about that we don't really need to know the distribution, right? We don't even need to know the causality. It's like the population, almost like that. So you're gonna predict things, but really in real life, we realize that one is that the stability of the prediction is an issue, and also interpretation of this is an issue because you really don't know enough about the structure. So those are the things that it's going to evolve. So when you predict what's going on right now and in the next 1 month or 1 day is different.
100%, right? So the tools, AI tools will and do fail if you try to use them for causal inference. Okay, so let me give you an example, and this is like I think this is where you're going. So let's say you're a hotel, okay, and you decide to use an AI to predict which price you should charge. And if you look at the hotel's underlying data, you'll see that, and you use the AI, and the AI says you should charge an infinite price. Right. Well, why does the AI say you should charge an infinite price? Well, if you look at the hotel's underlying data, during the periods when they're busiest and capacity is full, their prices are highest. And if you don't separate supply from demand and you naively look at the AI as a prediction, you just automate, okay, do what the AI says, it's going to clearly steer you wrong. Similarly, in early AIs for playing chess, the AIs would often sacrifice the queen early on in the game. Why? Because when the grandmasters sacrificed their queen, it was because they were right about to win. And the AIs learned the wrong lesson because they didn't sort of understand the objective. And they learned, oh, you know what? A great predictor of whether somebody's going to win a game is that they sacrifice their queen. Okay? They do something really dumb. And that particular problem has been solved. But the more general problem is if you fail to recognize that there's a data generating process. And if you're trying to predict something that's off the support of the data you have, that ignores the data generating process, the AIs will fail.
Fine. I'm just trying to,
Yeah.
I guess we're going to hear your talk. So at the end, we can kind of revisit this, just kind of how much you're going to shed insight on this. Thanks.
Okay. And it's there's a real role for human judgment in sort of doing the separation between, can we automate or do we need a human in the loop to make sure that we're not ignoring that data generating process?
Sure.
So, right, we have this extraordinary, we've seen, applications in banking, insurance, medicine, image recognition, writing, image generation, all sorts of startups. And you see many of the leading thinkers in the world saying things like, well, AI is going to be more profound than electricity or fire, or artificial intelligence, that's the new electricity. And in prediction machines, we started to imagine what that might look like. So imagine and turn up the dial on your prediction. They get better and better and better and better. So for example, think about recommendation engines. We're North America based, so we think about Amazon's recommendation engines. And their recommendation engine is really good. So for every 20 items you ask they recommend to you, you'll buy one of them. Okay, they're about 5% accurate. And if you think that there's hundreds of millions of products in their catalog, it's a really good prediction tool. But it hasn't been transformative. What do I mean by that? Amazon, their retail side is still fundamentally a catalog company. You order something from their catalog, it's a fantastic catalog. It's the best catalog that we have access to here in North America, but it's a catalog company. You order something from the catalog, they send that information to the warehouse, they ship it to your door. And we said, well, imagine turning up that dial. Instead of 5% accurate, it was 10 or 30 or 50 or 70% accurate. Well, at some point, you're not going to wait for them to ship the item to you. At some point, Amazon is going to say, I know what you want with enough confidence that I'll just ship it to your door. And I'm going to grab a big enough share of your wallet that it's worth it for me to build an infrastructure for returns even when I'm wrong. Now, we don't know if Amazon is going to build this thing, and we didn't know if it's going to happen at scale, but we did notice that they wrote this patent for anticipatory packet shipping from Amazon Technologies. Thought, oh wow, okay, the future is coming. But then here we are in 2023, and well, this patent's from 2013. It hasn't happened yet, and has certainly received a benefit from its AI spend, and a handful of other big tech companies have. But if you look at the overall survey data, most companies have not adopted artificial intelligence. And even among those who have, only a fraction report receiving a benefit from that spending. So how can we reconcile very smart people saying that AI is more profound than electricity, or AI is the new electricity, with the reality on the ground that most companies have yet to see an impact? Maybe it's time to learn a little bit about electricity. Okay, so Edison's patent was from 1880. He first demonstrated the electric light bulb in the United States in 1879. Tesla's patent for the electromagnetic motor, the AC current motor, was 1890. So if you were paying attention in the 1880s, it was clear that electricity was going to be a big deal. But it wasn't until the 1920s that half of American households and half of American factories were electrified. It took 40 years from recognizing that electricity was going to transform the way we lived and the way we worked, till it impacted most people at home and at work. What took so long? Well, here's what a factory might have looked like in the 1880s. There's a big steam engine at the center of the factory. And all the other machines in the factory are connected through these belts to that steam engine at the center of the factory. And the organization of the factory was determined by the power source. Because if you remember your high school physics, the further away you are from a machine, the longer those belts will be, the more energy gets dissipated. And so the logic of the factory was determined by the need to reduce that energy loss by having the power from the steam engine travel a long way. And so what happened when electricity came about? Some factory owners realized it would be cheaper. They wouldn't be losing that energy from the belts. And they might have had an easy electricity power source nearby, or they might have had difficulty getting coal to their factory. And so they replaced the steam engine at the center of the factory with an electric motor, but kept the factory the same. So some greater energy efficiency, some fewer line shafts and friction losses. But ultimately, they didn't, all they did was take out the old process, drop in the new process, and keep the workflow the same. And even by 1900, for most factories, that wasn't worth it. To just do what they were doing a little bit better, a point solution, taking out the old process, dropping in the new process, not messing with the workflow, the ultimate benefit was saving 5, 10, 15% on energy costs, which wasn't worth such a major change to the way things operated in terms of steam engine versus an electric motor. But then around 1900, a handful of enterprising factory owners realized that electricity wasn't just cheap power, but electricity was distributed power. It allowed you to decouple the power source from the machines in the factory. And that meant you could organize the machines differently. You had flexible machine placement. And that led to the quintessential 20th century American factory that you might imagine, with inputs coming in one end, outputs coming out the other, modular production, which led to a massive increase in productivity. And it was at that point we saw a change in the trajectory around 1900 to much more rapid adoption of factory mechanical drives. And similar things were happening in lighting and appliances and elsewhere. This co-invention, these other invention processes led to a change that was where we really got the benefit of electricity. For AI, in 2023, it's like we're in the 1890s. We see the potential of the technology, but for the most part, what we've been doing have been point solutions. We're in the between times because we've recognized, wow, AI can do medical diagnosis, it can do image recognition, it can help us predict whether someone's going to pay back a loan, it can help us with our current drug discovery process, it can help us give recommendations, but all within existing workflows. Most companies, most organizations have not begun to reimagine the workflow as a consequence of better, faster, and cheaper prediction. And that's why we lead to most companies that adopt don't report benefits, and most companies don't even bother to adopt in the first place. Now, there's a couple of industries where we have seen something like a system level change, not just a point solution where you take out the old process and drop in a new, but better prediction technology has led to an entirely new way to deliver value to customers. Think about professional driving. So there are 30 years ago, there were hundreds of thousands of people in the United States who made a living as taxi drivers. And a big part of their job was getting from point A to point B as efficiently as possible. So you hail a cab and you say to the taxi driver, I'd like to go to, in London, you're at Buckingham Palace, you'd say, I'd like to go to the Botanical Gardens, and the taxi driver will be able to get you there. And navigating London is difficult. And so it's a real skill. Actually, in London, it's 3 years of training to be able to get a taxi license. And a lot of that training is about navigating the city and predicting the best route from A to B. About 15 years ago, a new technology came about, which was navigation AIs, navigational predictions anyway, that helped you get from point A to point B as efficiently as possible. At the same time, there was a digital dispatch technology that happened through a phone and predictions about where there'd be people who might need to get picked up. And what happened at first is that technology was used as a point solution. If you were a professional taxi driver in 2009, well, you were suddenly much better at your job than you used to be. You could get from point A to point B more efficiently. It might save you 5% in time, make you able to have more fares. You might be able to use a prediction that helps you, a prediction technology combined with your mobile phone to pick up rides faster. And so this was used at first as a point solution, the professional drivers. But what we've seen in the ensuing 15 years is a system solution. The recognition that this isn't just about making professional drivers better, but once anybody knows how to get from point A to point B, we can have an entirely new way of doing things where we make amateur drivers professional. Navigation AIs, digital dispatch, some verification technologies to build some trust, combined created an entirely new way to help people to get from point A to point B.
Avi, how are you?
Yes.
Hey,
Leon, how you doing?
Good to see you. So I have a question related to this slide. So maybe this is a good time to ask a question. So I want to I'm very interested in your view, what's the defining feature for machine versus human? So now there's a lot of discussions about whether like a ChatGPT can replace people, replace writers or researchers or analysts. From your previous slide, it seems you are suggesting those kind of machines and humans sort of complementary, kind of machine plus human will be better. But in terms of defining features, how to think about what is a machine, what is a human in terms of decision making? All like you input the data, you have a code, and you have a model and generate the information and make a decision. And in that model, that framework, people and human and machines are very, very similar. So we just see people just use experience in the past, or even our kind of ancestors from hundreds of millions of years ago. So we have some genes, we have a code, we know how to interpret reality. This is also similar to a machine if you think about a very, very long history. So in that sense, I think people and machines are very, very similar in nature. And if we want to write in model in economics, what's the defining feature? What's a machine? What is a human? And what's the relation between them? Substitute or complement in what domains? How should we think about the unified framework? So thank you. The question is very open. It's very wild. I hope it's kind of.
It's actually getting me right where I want to talk about next. So it's a beautiful question. You didn't even know it. You like set me up for the next thing, which is so. I don't know about what the difference between what makes somebody human. That seems like a philosophical question, but I can tell you what the current generation of AI does. It does prediction, and predictions are useful because they better decision making is a big deal, right? We make big decisions and small decisions. Organizations are fundamentally about decisions. Predictions in and of themselves, without a decision underlying it, are useless. So when we think about the opportunity in AI, it's this combination of, well, a machine's now making a prediction. What's the best way to think through who is responsible for the rest of the decision? Okay. Some of those other parts of a decision a machine can do, like actually take an action, do something. And some of the other parts of a decision, what we call judgment, which at a high level is like knowing which predictions to make and what to do with them when you have them, that remains human. But what AI does is it can change the human who makes that judgment. That's what I'm going to talk about next. So right now, in the absence of AI, when you make a decision, there's a human prediction and a human judgment combined in your head. Okay, so there's some scoring about the likelihood of different events happening, and then there's the judgment about the payoffs. Like, okay, is this good or bad? So formally, actually you asked formally. So formally, the prediction is the probability of different states of the world, and the judgment is the utility function or the profit function at the end of that, the payouts. And so, and it'll be all the branches of the tree, essentially. And right now, in the absence of AI, you're combining the prediction and judgment in your head. What machine learning, what today's AI does is it makes that prediction done by a machine and decouples it from human judgment. And that's what's so disruptive. Just like what electric motors did is they decoupled the power source from the machines, and that led to new opportunities for factory organization. AI decouples the prediction from the judgment, and that leads to new opportunities for decision making and potentially transfers in power, because ultimately power comes from judgment. It's the ultimate ability to decide. So let me give you an example of what I mean by prediction and judgment. I think this will answer, help answer a handful of the questions I've heard so far. So there's this movie, I, Robot. Not sure if you've seen it. It's a fine movie, and it's great science fiction. Okay, it's great science fiction because there is this flashback scene where the detective, Will Smith, who's the protagonist of the movie, talks about why he hates robots. Okay, so here's why. When he was younger, he's still an adult, and he and a little girl were in a car accident. And for whatever reason, their cars go into a river, and they're both sinking. And it's pretty clear that both the detective and the little girl are about to drown. And then a robot comes along and saves him and not the girl. And that's why he hates robots. But then a robot comes along. So why did the robot save him and not the girl? Well, it turns out the robot predicted what did he have? He had a 45% chance of survival. And the girl had an 11% chance of survival. And that's why the robot saved him and not the girl, because 45 is more than 11. And he says, but 11% was more than enough, and a human being would have known that. I don't know. That's a statement about judgment. That's a statement about payoffs. That's a statement about our values. That remains inherently human. But when we separate the prediction from the judgment, there's all sorts of things that get uncomfortable. And we don't like talking about the relative value of one life versus another. It's convenient that we have the prediction and the judgment in our head, so we don't have to face the reality of how much we value one thing versus another. But also, when we get this separation of prediction and judgment, old decisions that seemed right, because we didn't really know for sure what was right or wrong, become very clearly, some people's judgment becomes very clearly not the judgment you want. So I'll give you an example of that. I don't know if you remember a few years ago, the city of Flint, Michigan had this water crisis. Okay, there was lead in the water, okay, massive amounts of lead. And two professors at the University of Michigan, Eric Schwartz and Jacob Abernethy, built a machine learning tool, built an AI to find lead. And that was really useful because in the absence of an AI, the only way to know for sure if there's lead pipes leading into a house, and lead is, obviously, it's a toxic, deadly neurotoxin, you don't want it in your water. The only way to know for sure is to actually dig up the pipe. Once you've dug up the pipe, it's pretty easy to replace. But digging up a pipe takes time and thousands of dollars. And so they built this AI to predict which pipes had lead, and it was working. It was working great. The base rate for lead pipes in Flint was about 20%, and their AI was finding lead 80% of the time. So it was 4 times more effective, and thousands of people were now drinking safe drinking water faster than they otherwise would have been, getting their pipes replaced. But then people started noticing that, hey, how come the people down the street, they're getting their pipes dug up and my pipes aren't getting dug up? Or how come that neighborhood over there is getting their pipes dug up and mine aren't? And they complained to the city, and they complained to the city councilor, and the city councilor said, well, you know what? That squeaky wheel, you guys are right. It's not fair. Why are we listening to these random University of Michigan professors? Let's do something fair, go street by street, city by city, systematically through Flint, and forget those predictions. And what happened is the success rate plummeted from 80% to about 20%. And it seems like this wonderful story about AI in public health and making people's lives better ended up going wrong. But it didn't actually stop there, because this graph is so stark. It is clear what the right and the wrong decision was, that people sued, and a judge came along and said, no, the right move is to listen to that machine learning algorithm. It is now the law in Flint, Michigan, to listen to Eric and Jacob's algorithm. And their company has now been scaled to dozens of cities around the US and around the world. And once they started using their algorithm again, the success rate went right back up. But this is a story about how this prediction from the judge is very disruptive. It changes who makes decisions. And the resistance is often going to come from the people who benefited from the old system. People who wanted peace of mind that they didn't have lead pipes, but were very, very unlikely to have them, which were people in the nicer neighborhoods who might have had more political power. So the first way AI disrupts is the decoupling of prediction from the rest of the decision. The second way AI disrupts is decisions don't occur in isolation. Every decision we make in an organization is reliant on and depends on other decisions, and is built upon by other decisions. Okay, and so if the people in the organization don't know what each other's doing, forget the AI. Maybe we'll just always do the same thing. If you have a recommendation engine and you don't know what's in inventory, you're just going to recommend the most popular product at all times. So this symbiosis that different decisions within an organization need to be coordinated shows up in one place. It shows up is in sailing. Okay, so I don't know anyone here is listening is a sailor. This is the boat that won the first America's Cup race. It's it is the oldest continuing professional sports trophy in the world. It's a sailing trophy. And if you look at this boat, it looks like a sailboat. And to win a sailing race, you need a great boat and you need great sailors. There's sort of two different decisions. But over the course of the 20th century, we moved from boats that look like this to boats that look like this. It barely looks like a sailboat anymore. It's kind of a flying ship with a connection to the water. Okay. Most of that innovation happened in the boat because we learned how to simulate boats. But innovation was always constrained by the sailors. We couldn't really invent new ways to sail faster than sailors could actually sail the boat. But Team New Zealand, before the most recent race, realized, well, with better simulation, we don't just need to simulate the waves in the water and the sailboat, the design, but we can actually create an AI sailor and simulate sailing to figure out which boat designs work best with which new kinds of sailing. And so it was that innovation, not just in one part, but in both core decisions involved with winning a race that led to their success most recently. This is the essence of what we call digital twins, which is what we used to call simulation, but simulation at a scale where we can model multiple decisions and change multiple decisions at once. So how does AI disrupt? It's through the decoupling of the prediction and the judgment, and through the recognition and the challenges on the symbiosis decisions within order. Now, most industry people then say, okay, this all seems very abstract. You've said I can wait 40 years. Electricity took 40 years. Computing took 40 years. Is this going to take 40 years? Can I just relax? Should I worry? Well, that ultimately depends on whether you're satisfying your customers and fulfilling your mission. Think about the best airports in the world. This is Seoul Incheon. There's a handful of others that fit in this category. They tend to be pretty spectacular. Okay, they're multi-billion-dollar pieces of architecture. They have fantastic shopping, great restaurants, museums, even massage chairs, gardens, greenhouses, hotels. They're amazing, right? But almost everybody would rather fly through this airport. This shed, why would you prefer this airport? This is the private terminal, I'm told, at Boston Logan Airport. This is how the super rich fly. They don't fly through multi-billion-dollar airports. They fly through airports that look like this. Why? Because they don't have to spend any time at the airport. Seoul Incheon's mission is to ensure smooth air transportation. That billion-dollar architecture has almost nothing to do with ensuring smooth air transportation. Much of what they do at Seoul Incheon is dealing with the fact that we don't know how long it's going to take to get to the airport, and they don't know how long it's going to take to get through security. And so we spend billions of dollars of compensating, making people feel better about the fact that we're not really ensuring smooth air transportation. And there's lots of industries where this is true, where much of what you do is focused on, rather than focusing on how do we serve our customers better, it's how do we deal with the fact that we're not quite fulfilling on our mission, and what can we do to make up for it? So the way to think through whether this is coming for you is to first assess, what's the goal of my organization? What's our mission? What are we trying to accomplish? And then how much of our standard operating procedures are focused on achieving that mission versus how much of our standard operating procedures are focused on compensating for the fact that we don't really serve our customers as well as we could? If the answer is a lot of what we do is about dealing with the fact that we don't serve our customers as well as we could, then ask the third of information. If we had prediction machines, could we then move more of our standard operating procedures to being about serving customers as opposed to compensating them for the fact that we don't serve them as well as we could? Thanks very much. We have some time for questions.
Great. Thank you so much, Professor Goldfarb, for your insightful presentation. So if anyone has any questions, feel free to raise your hand, put it in the chat, or actually just ask away. So maybe I will take a moderator's prerogative and start with a question myself, which is, given Professor Goldfarb, you work with a number of entrepreneurs in this space. So maybe I'm going to try to not use the word prediction, but maybe you can give us premonitions for the future. So what are the areas where they are finding immense gaps and opportunities in this fast evolving space?
So for the last 10 years, most of the entrepreneurs we've seen have been providing point solutions. They're like, okay, let's go through an existing industry's workflow, identify something where there's a lot of cost because of bad information, provide good information to that one place, and then make their existing workflow more efficient. And we've had some success at the Creative Destruction Lab through the graduates, through our graduates in AI, of point solutions that take an existing workflow, don't mess with the workflow, and make one little part better. But I think there's a real opportunity now, especially with the advances we've seen in generative AI, to transform industry. Okay. And what I mean by that is, yes, it's always easier if your startup is fitting into an existing workflow, but that creates a ceiling to how big a deal your company can be. If you're not figuring out a new way to generate value, sort of reinventing the system through which an industry operates, then what you're going to be doing is creating solid companies, but not transforming the world. And the biggest opportunities are where we go a step further and try to think through, well, if this whole industry operated differently, like once we have great predictions, once we can fill in, we have this relevant piece of information, then what can we do that's totally different from what we did before? And so what we're seeing in the lab this year, so our thesis in our AI stream this year is focused on trying to find system solutions, are people trying to reinvent industries through AI, recognizing the value of prediction. So we've seen people trying to reinvent the industrial kitchen, the restaurant industry, but especially where they're, once you have the ingredients, prediction has made visual processes good enough, and a whole bunch of other pieces like robots are getting better largely because of image recognition and some other tools, that we can have an entirely new kind of kitchen that is flexible in terms of what kind of food they offer, high quality, consistent quality, and can be in many more places with fewer resources. So you can imagine, like right now, if you're a college dorm or a retirement home, have an industrial kitchen, and you're very constrained by who you can hire and what kind of food you can offer. With better prediction, we could enable those kitchens to be just totally different. They would look different. They could be much smaller and much more impactful. So kitchen, like the restaurant industry, is an industry that we can see transformation. Another kind of example is through the digital twin, for example, idea. Lots of industries, healthcare in particular, are constrained because we don't have good models of the world. And, in healthcare, you can imagine building much richer models of the human body that allow us to simulate the impact of a new medical device or a new molecule on that body. So right now, our models of the human body are quite abstract. We really think about them at the level of the protein. And trying to get a full-scale model of humans, and ideally of the particular human who needs to be treated, will allow a totally new kind of personalized medicine that I think is super exciting.
Great, thank you.
Hi, Professor Goldfarb, and thank you for your wonderful talk. And I'm wondering whether you would be concerned about AI's impact on the labor market, especially on the low-skilled and middle-skilled workers.
Great question. Yes and no. Okay, so in the what do I mean by that? Disruptive technology any technology that's going to transform industries is going to lead to almost by definition disruption. Means some people are going to win and some people are going to lose. I think with AI, more people are going to win than lose, but that's not to say that the people who are left behind, we should just ignore them. So like, I am worried in that sense. But I'm optimistic about high skilled versus low skilled. More optimistic than I would than you'd think, given what happened in computing. Over the past 40 years in the US labor market and Europe, so I don't know what's happened in the Chinese labor market the same way, but in the US market and European market, we've seen an increase in inequality, largely due to technology. So the internet and computers, in order to get a productivity gain, labor productivity from those things, you need to have skills, particularly you need to be relatively well educated. And we've seen what we call skill bias technical change. David Otter is the leading scholar in this area and sort of developed a lot of the work. And he showed that as the previous two generations of information technology diffused, it's been great for people who are high skilled and not so good for people who are less skilled, especially the middle income. So we've seen an increased inequality. So that's where I think your starting point. I think there's reasons to be optimistic that prediction machines are doing are largely automating the work of people who currently are at the top of the income scale. Okay. And so if you think about medical diagnosis, for example, doctors do pretty well. And if a core part of their workflow gets automated, that's not going to be good for doctors. And that's the point, but it might be good for inequality. Okay. What do I mean by that? In the US, there's hundreds of thousands of doctors, but there's millions of medical professionals, nurses, pharmacists, medical assistants, social workers, and others. And one thing that doctors do as part of their workflow that no one else really has the skill of or the ability to do is diagnosis, prediction. But if we have machines that can do prediction and we build some training programs to help nurses and pharmacists and others leverage those prediction tools, what we can think of as upskilling millions and millions of workers to be able to serve, so increase their marginal productivity, increase their wages, and increase their ability to help people and deliver better healthcare. That, to be clear, that's at the cost of a smaller number of people whose job opportunities are going to be diminished. And so so it's there's going to be winners and losers. Don't ignore the losers, but I'm optimistic that the current generation of AI prediction tools, a lot of the winners are going to be people who we currently think of as low skilled, because we shouldn't be thinking of them as low skilled. We should be thinking of there's a constraint on their ability to leverage their skills in the marketplace. And so I did it with diagnosis. ChatGPT is another example of this. And where those of us who make a living writing, we see what ChatGPT can do and you think, there's now a machine that can write. That was inherently human. That was a skill. I make a good living off writing. I'm not so thrilled about a machine that can do that. But there are many more people whose job opportunities are constrained by their inability to. What do I mean by that? There was this story, and I don't know how, I can't verify the veracity of the story, but there was a story on Twitter of a landscaper who was a good landscaper, but was a terrible writer and didn't know how to write a customer service email like, "Hi, Mrs. Chen, I'm going to be at your house Wednesday to work in your garden. Thank you." He didn't know how to write that email, and he had a hard time getting business. And somebody helped him build a tool that could automate his writing using the underlying technology for ChatGPT. And that enabled this person to get a lot more business. That's one example. Who knows? It's an empirical question whether it'll scale, and we won't know for a while. But it's an example of one person's automation is another's augmentation. And prediction machines seem to be automating the skills. Maybe this is what people are worried about, but the skills of the people who already make a really good living. And in the process, they might be augmenting the people who we currently think of as low skilled, because their bottleneck to really delivering the value they can in the workplace has to do with writing or other things that machines can do.
Hi, Avi.
Hi.
Yeah, I just want to follow up with what you said. I think it's interesting direction to follow even for the academics and of course for the general public. So I think all earlier automations, people have realized that it's not really increasing the unemployment or stuff like that. But when AI came, a lot of people came worried, right? And it's like it's a hypothesis. And now you seems to be more optimistic than a lot of other, including David. And I think there could be good reasons, as you claimed in your presentation. If it can change a lot of amateur to become professionals, maybe that really makes them competitive. At least maybe it could reduce the gap between them and the high powers. But that's another hypothesis. So I think it's really interesting to follow what's going on this.
Right, and David and I have an ongoing debate on this very topic. So, okay, so there's a thing you model-wise, you got to take a step back. So there's two reasons why we've seen increasing inequality over the last 40 years in the U.S. Sort of stopped relatively recently, but there's two broad forces. One has been skill-biased technical change, which is differences in labor income between people who are educated and people who are not. And that's actually the force I'm talking about. There's another force which is related to capital labor share, that more and more of the economy of GDP is from capital, and that leads to inequality as well. And actually, there's reasons to be very pessimistic about AI because it's capital, okay, and it takes a lot of capital. So my optimism is very much about labor share and not about capital. Capital tends to be about the 1% versus the 99% is capital, and that the top 10 versus the 90 is more labor. Now, David's work in the 80s and 90s showed quite convincingly that David Otter, that increasing inequality was because of the automation of what middle income people were doing through, especially in factories, through what we called robots, but these were not intelligent machines. They were, automated processes within factories and a few other places too. Same thing happened, there's a different process that happened in office work where the fact that all of us have our own computer replaced typing pools and replaced a whole bunch of what we used to call pink collar jobs. Okay. Now, so one version of the story, and this is where David's coming from typically, is that AI looks like information technology. And we know that information technology is skill biased, so why would AI be any different? Where Ajay, Joshua, and I are coming from in this topic is to say, well, it is different. If you actually listen to David's frequent co-author, Doron Asimoglu, when he talks about what AI can do, it's about automating particular skills that the high-waged humans have. And Doron argues that that's bad. We don't want to automate the things that high-waged humans do. And Eric Brynjolfsson's arguing something similar. And this all goes back to John Markov's book, Machines of Loving Grace, talking about the differences between augmentation and automation. And what we're arguing, we're going to have a piece coming out on this soon, is that one person, first, there's no real such thing as augmentation. One person's automation is another's augmentation and vice versa. And so the real question is, which humans is the technology going to substitute for, and which humans is the technology going to complement? And the optimism comes from a hypothesis, not proven, to your point. Like, we need data. Like, please, some of you, get some data. Okay. Start analyzing it. But a hypothesis that these technologies are about automating processes at the top end of the wage scale. So it'll automate them and augment the rest of the population of the process. But it's, let me be clear, what we're arguing is hypothesis, and what Doron and David and Eric are arguing is hypothesis. It's too soon. We don't have data yet.
Yeah, so a lot of the interpretation so far, I think the causality is not very clear. So there are a lot of reasons. So people just go with what they're comfortable with. So we'll see. But it's really interesting opening up new grounds to follow.
Thank you.
Hi, thank you, Professor. I have a quick question. It's really powerful, insightful observation regarding the decoupling of prediction versus judgment. I'm wondering if you could go into more detail regarding judgment. So wouldn't the most rational judgment in most of the scenarios be based on the most comprehensive prediction? And other than your example regarding morality, regarding human value and humanity, what are the other scenarios where you think judgment is truly human and is really human judgment rather than an extension of machine prediction?
That's a great question. So at the limit, it's judgment is a statement about what we value, and ultimately, whatever decision you're making, your values are going to be part of that decision, and so that's inherently human. Now, in a technical sense, you might say, oh, well, we could just have the machine predict human judgment. In fact, that's what conjoint analysis was. Like the early demand estimation in marketing, the whole literature that like Vitala Rao and Paul Green in the 1970s was trying about was about predicting human judgment, the judgment of customers about what they wanted. And so then that gets to the limit of then the next step is, sure, now you need to decide what you want to predict, and then you need so there's a judgment on figuring out which judgment you want to predict. And the real technical limit is about data. Okay, so some things are rare, and some things are going to be off the support of the data you have. And prediction tools don't help you there. And so that just ratchets up the judgment to the point where this is something that there's not ground truth, and it's not something we can learn from lots and lots of observations because it's inherently rare, like elections that happen every 4 years and the world changes, or it's inherently impossible from sort of the Rubin causal model of we never can see the counterfactual. And so, and because we can never see the counterfactual, we can't rely on prediction machines to solve it. And so we need to embed some human judgment about what matters and what we're trying to accomplish. It's a great question. We have it's about a chapter and a half of prediction machines dedicated to this subtlety about when you should, the limits of judgment.
So
Thank you.
I want to follow up on this quickly. So it seems like, nowadays what we're finding is, now that we have the technology of cheaper predictions, there's a saying that when you have a hammer, everything's a nail. So we're finding more and more problems are actually prediction problems. And maybe even some of the things that we nebulously thought were judgment before is prediction, or at least at the border. So I think the question is, when does the combination of cheap prediction taking over more and more of what we think are human, we need humans for tasks, combined with human ingenuity and programming, when does that start to kind of, the combination of the two take over more and more of what we do day to day, right? So
I think ultimately you're still going to need somebody to say which prediction should you make and what should you do with them.
Well, could that be very
the real disruptive force?
The dystopian case, right?
The real disruptive force here isn't that the machines are making decisions. It's that some small number of humans can make decisions at scale. And so, so think about a machine for like AI for hiring in a workplace. Okay. Right now, most workplaces, when they do hiring, there's human resources managers on the ground who look through resumes and do interviews and then decide who to hire. And maybe eventually it goes up, further in the organization. But there's for a big company with thousands of employees, there's multiple human resources managers who are doing this interviewing. Now we have an AI that will help us predict some measure of success. Okay. And someone at headquarters, maybe even one person, can say, you know what? this is what we really care about in our company. And let's build an AI that predicts whether each individual applicant, how they're going to score on that thing we care about. Okay. And so what's happened is we've moved from dozens or even hundreds of HR managers to potentially one person in the whole company making all of the decisions. And that's dystopian. So we think about like, that might be an opportunity for the company, but we worry about dystopian AI. As long as we're in a world of prediction machines, the worry isn't that the machines are going to start making decisions. It's that a small number of people can now make decisions that that affect everybody. And so it could lead to a massive centralization of power.
Okay.
Hi, Avi. This is Stacy from Luohan Academy. I want to raise another example. Like in fintech lending, the lender will involve AI in his work, and the AI will help him to predict if the lender is qualified or not and make loan insurance decisions almost instantly. And in my understanding, in this circumstance, the prediction and judgment is coupled in AI. So will this what you call decouple exist in all circumstances, or this decouple just exists in some circumstances?
So what happened there is the person who set that prediction technique. So now the decoupling happens, right? So on the ground, what the AI is doing is, each loan request comes in and it's providing a prediction score. It's just doing a prediction. Some human in a company has decided what is the threshold for giving this person a loan or not. Okay, so that threshold is the judgment. Or there's two parts to it. One is the threshold and two is the scoring rule. And so what's happened is the decision has been automated. Because of the decoupling of the prediction from the judgment ends up in this case being codifiable and can be pre-specified. And so the difference here between sort of the old loan officer at the bank is the loan officer would make a prediction individual by individual and then apply their judgment individual by individual whether to give the loan or not. What AI enables is you to pre-specify the judgment, and so that by pre-specifying the judgment, you end up automating the decisions, but that doesn't mean the judgment isn't human. It doesn't mean it's not a human decision. It's just change the human who's made the decision. So AI, like another way to think about this is, it's not that machines make decisions, but machines change the humans or can change the humans who make decisions. And often that leads to a centralization of power. Sometimes it doesn't. Sometimes it can go in the opposite direction too. It can empower people on the ground to make better decisions.
Okay, so I should note that we do have to hard stop at 10 after. So Professor Goldfarb has graciously extended a little bit. So I think we have time for one more question. Okay, great. Well, if there are no more questions, Professor Goldfarb, thank you so much for the presentation today. Certainly good luck with the rest of the book tour and everything else that's keeping you busy these days. And we really look forward to more interactions with you on this crucial topic in the future.
Okay, it's been great. I really appreciate you inviting me. Take care, everybody.